This organization runs a service to monitor customer satisfaction. They rely on a platform that enables them to respond to changes quickly. How? GitLab DevSecOps Platform offers tools to the platform engineer to implement DevOps practices that automate the heavy lifting that enables continuous delivery. Let's consider this scenario. There is an incident where it was detected that one of the services from our application is underperforming. Developers using issue boards can prioritize working on this incident. We can see here that the incident is related to a previously open issue and contains a task with a necessary step to close this incident. The developer creates a merge request to add the code changes specified in the task. The changes are done using the Web IDE, which is an advanced editor to make changes to multiple files directly from the GitLab UI. We can see here the fix is applied and committed to the merge request branch. We see continuous integration in action here. Through the native support for continuously building code, the fix applied triggered a set of automated steps in charge of building, testing, and scanning the code for known vulnerabilities. A platform engineer configured and defined these steps to ensure our application is secure and compliant. We will go deeper into these scanners later on. Once the CI pipeline has finished, we get a full report of the impact of this code contribution. We see no known vulnerabilities were introduced. The code quality did not decrease. All the tests passed, and we got feedback from a reviewer. The changes are merged, and once more we see in action GitLab DevSecOps Platform by automatically triggering a CD pipeline that will speed up our path to production. Once the CD pipeline has finished, we can see under deployments and environments that our fix has been deployed to production. The process from incident to resolution looked pretty efficient, and as a platform engineer, I want to have visibility of processes like this and the time it takes our organization to deliver value. To gain that visibility, GitLab DevSecOps Platform provides the 4 DORA metrics available out of the box in the Value Stream Analytics dashboard, helping us to visualize end-to-end the entire software delivery lifecycle and streamline the evaluation of the effectiveness of our development and delivery practices. The service to monitor customer satisfaction is designed as a cloud-native application with microservices architecture. Each one of the dashboards comes from a different service with its respective code base. When a deployment is executed, there is an orchestration and delivery to different environments. One way to illustrate how to build and deliver for hybrid and multi-cloud environments is by using an orchestrator project with a GitLab CI/CD pipeline that, when triggered, will automatically start the build, test, and deploy of each of one of the microservices to different cloud environments. Now, as a platform engineer, I have configured GitLab Kubernetes integration to build, test, and secure deployments to a Kubernetes cluster. Let's take a look at a single project and how, when developers make changes to the application, for illustration purposes, a change to the header on this web app, a new container image will be built. This container will be scanned to make sure we are not using images with security vulnerabilities. In addition to that, we apply other security scans to keep the application secure and compliant. Following a GitOps pattern, as a platform engineer, I want to model independently the build of the application from its deployment. To achieve this, when this application is built and passed all the tests, I want to use multi-stage pipelines to pass the container image tag that we just built to another project in charge of the deployment. From the pipeline, we can navigate to the cluster deployment project. This deployment project will change the Helm charts definition of my application by doing an automatic commit to the manifest files. And thanks to GitLab Kubernetes agent integration, the cluster will notice this change and pull the new image that was built and secured. We refresh the cloud native application a couple of times, and here we go. We can see that thanks to GitLab DevSecOps Platform, the application was built, tested, secured, and deployed following a GitOps pattern. The service to monitor customer satisfaction comes with a mobile version natively built in Swift. GitLab DevSecOps Platform can help to automate CI/CD pipelines to build, test, and release a mobile application. Developers can work from their development environment, commit and push changes to GitLab. We see here that as a platform engineer, I have configured development workflows for mobile developers. The previous push to this merge request automatically triggered a CI pipeline that right now is in charge of building this Swift application and applying mobile security scans for iOS. And how is that iOS developers, in this case, can build applications using CI/CD pipelines? Well, as a platform engineer, I have configured GitLab macOS runners. GitLab macOS runners that are in charge of running this app, build it, and test it. This hardware gets automatically provisioned to the developers without any extra effort. In addition to that, a mobile app requires a set of provisioning files and certificates that must be consumed during the building and testing process. GitLab DevSecOps Platform provides a way of using secure files to store keys and certificates that are consumed in the mobile workflow. Going back to our pipeline, we can see that it has finished. To illustrate the release process, let's merge the changes and observe that a new pipeline with a release stage has been created. If we check what is happening inside this macOS runner, we see that the application was successfully released and is ready to be tested. I should have a notification in my phone and an updated version of the app. And yes, here it is. The application is ready to be used in my phone, and the process from code to release is streamlined thanks to GitLab DevSecOps Platform for mobile. Manual, time-consuming, and error-prone processes for enforcing control and requirements can be a challenge in highly regulated industries. GitLab, a single DevSecOps platform, automates compliance workflows, reducing overall business risk. Let's take this project as an example. As a platform engineer, along with a compliance manager, we have defined compliance workflows. The compliance manager has defined a framework, and I have defined the required CI jobs to fulfill the framework requirement. We can see in this project that by applying this label of SOX compliance, we bring extra attention to the requirements this project must fulfill. And how do we automate the compliance workflow? Separating duties and using a different GitLab project with the compliance policies that my project must execute. Here we can see in this compliance pipeline that jobs for SOX compliance have been defined and a path to the project that must run these jobs. This project can be maintained by a compliance manager and updated to meet further requirements. All of this away from the development project, keeping this way the different personas focus on what they know how to do best. Whenever we run a pipeline in this project, the compliance jobs will be automatically inherited, making sure that they are always run and stick to the compliance manager definitions. And that is the effect of tagging this project with a certain compliance framework label. Running compliance pipelines in my project brings with it visibility into the different licenses my project uses and allows me to enforce policies about licenses we can or can't use. In addition to that, having security embedded with preview dependency scanning for SBOM generation allow us to gain insight into the dependencies my application uses. Another capability that helps us in the auditing process and compliance is GitLab auditing events. In the project UI, under security and compliance, audit events track important actions, including who performed the action and when. These actions can be exported and be used to generate comprehensive reports. GitLab DevSecOps Platform can be used to automate the software development process for ARM devices, ensuring that software changes are tested and secured in the development process reduces risk of errors. This is particularly relevant for ARM devices, which are often used in IoT devices in constrained environments. Let's check this project as an example. There is a routine written in C, the language for low-consumption devices. As a platform engineer, I have set up an ARM-based GitLab runner. We can see it gets automatically allocated to C developers by using this tag in the pipeline definition. Now, let's run a pipeline and see it in action. Let's click in the build job. We can tell by this command here that our app is being built in an ARM architecture hardware. Going back to our pipeline, and that GitLab DevSecOps Platform has automatically detected the programming language and is applying SAST scanners for C programming language. When this pipeline is done executing, we can see that it automatically created a package and published it to the package registry, making it easier for our developers to consume, download it, and work with it. GitLab DevSecOps Platform offers support for developer assets via templates that can be shared across the organization. Let's say that I want to use an iOS Swift template to kickstart the development of my mobile app. I select the template and I create my project from that. And in seconds, I have a project with the necessary blueprints to start coding. But it goes beyond that. I also have a way of discovering assets for CI/CD pipelines templates. All of these out of the box. In this example, I am choosing a Swift pipeline to build, test, and deploy my mobile app. To bring an app or product like this to life, we start by leveraging GitLab planning capabilities. Here, we can see how the organization building the application can organize itself by using groups and subgroups. These represent different teams working on different projects with its respective source code. As an example, here we have the codebase for the mobile developers and the different projects they are working on. And how are teams doing the planning, building new features, or managing defects? My product organization has the work organized in epics. This team has been working on large features that involve multiple discussions in different issues and projects. We use epics to consolidate those issues and track work. In addition to that, we have a roadmap view, which allows us to visualize milestones and the progress of the work being done and its completion percentage in a form of a timeline. This is helpful for leadership to get an overview of what's being completed and how far we are along that process. Now, let's take a look at labels. This allows me to answer the question of who is working on what in the organization and set up workflows and boards. There are different fronts needed to build a product like this, and the labels help us to find out which part of the product someone is working on. Alright, since we have planned it, let's get some work done. Going back to the issue boards, we can see here what is in the backlog, or switch boards and see the workload distribution in the team. I am at overcapacity right now. My limit has been set at 3 items and I have 4. You can also tell by my red background. I will pass one of my issues to Cesar. And now that the red is gone, I will focus in getting this issue about feature flags closed. Let's take a look at this issue to enable feature flags in my application. First, the issue contains tasks. These tasks are a breakdown of the necessary steps to be executed to consider this issue done. It has linked items, which establish a relationship between this issue and other work being done in my project. I better close this issue soon, since I can see it's blocking other work in the project. From here, we can also learn the hierarchy. This issue belongs to this epic. This epic groups all the different issues in different projects that aim for a common goal. In this case, to implement continuous delivery and release orchestration in my application. This issue also belongs to this milestone. This milestone has been defined to track releases. It tracks all the issues and MRs towards release 1.0. Burn up and burn down charts show us the progress of completing this milestone. And additionally, this issue is part of an iteration, which is where we define smaller timeframes. And as you can see here, I have to work on this issue during this iteration. Alright, let's create a merge request to add the work that needs to be done to enable feature flags. This merge request is automatically associated with the open issue I'm working on. When the work is done, as stated in the description, it will close this issue and reflect this in the status of our iteration and milestone. Alright, I have created a merge request, added a reviewer. Now, I want to use the web IDE to add the instrumentation needed in my application to enable feature flags. Using the web IDE, I can see in line 321, I have the feature I want to put behind a feature flag, which is a data panel that allows me to add a hashtag and get a predicted emotion with respect to a tweet. I commit the changes, and this will automatically trigger my CI pipeline, build my container image, scan containers, scan dependencies, code quality, SAST, and secret detection, right in the merge request. Additionally, I can start a code review, asking Cesar to review the lines of code I just added. When the pipeline is done, we get a full report of the impact of this merge request, from code quality to security vulnerabilities. We will go deeper in the GitLab security features in the next chapter of this story. At the moment, let's take a look at the pipeline executed for this merge request. We see all the security scans, including Dust, and let's bring our attention to the QA environment. As a platform engineer, I have defined the deployment of this environment as a manual job. Let's click on it to deploy it. Besides, this is the environment we need to test our feature flags configuration. Now, under deployments, we find the option to define feature flags. Let's choose a strategy since we already instrumented the application script. We see we can link the issue we are working on right now to the feature flags view. Alright, I want to use a %rollout strategy based on a random method and set 50 as a percentage. Down here, we see staging is the environment scope for this feature, which is the one we just deployed when we manually deployed QA. I save these changes and let's see it in action. Under deployments and environments, I get quick access to the staging environment or QA we want to use to test our feature flag. This is my staging environment. Remember, we set a %rollout of 50% and a random method. We can see here the predicted emotions data panel. This is what we put behind a feature flag. Let's try refreshing the app again. Now we don't see it. One more time. Here it is. One last. And it's gone again. The feature is off for this attempt. I think this little test is enough. We have seen how we can toggle a feature on and off. This helps us to do control testing, reduce risk, and achieve continuous delivery. And I have configured all of this without leaving the GitLab DevSecOps Platform UI. Going back to the issue, I can declare these tasks completed. Good, I did this on time. This issue has a richer view now, showing us the related merge request that will close it and the related feature flag that it was affecting. All of this help us to, at any point in time, get visibility of the work being done across different teams. We are quite close to finish our mission here. Going back to the merge request, I can see a full report of the impact these code changes will make to the application. We see it needs to go through some deployment approvals, code coverage, and as a platform engineer, I have set up code owners associated to a file. The reports are giving me code quality suggestions. This shows me good candidates for refactoring and improve my development skills. For demo purposes, let's pass on this and focus in the critical security vulnerabilities. One of my scanners detected this vulnerability in one of the dependencies. From here, I can create an issue to investigate this vulnerability and of course, involve the security folks from my organization to help out. In this case, the scanner is also providing me with a solution. Therefore, I will go and grab the latest version of this dependency that has been flagged as vulnerable. Having this, I can update my pip file where I manage my project dependencies, and I have also changed the Docker image to a different one with less vulnerabilities. When I apply all the changes and the pipeline is done, I can see here in the merge request all the additional commits that I have worked to fix the errors, providing full visibility of all the work that is being done in this MR before it gets merged. I can see that the critical vulnerability found in the dependency with the dependency scanner is gone, and the new image reduced the amount of vulnerabilities found in the container. Let's assume we are good to go, so we can see the next stage of my deployment. So I provide the respective approvals, the deployment approval, coverage check, and code owners. I resolve the threats from the collaboration with Cesar. And this is ready to merge. Before merging, let's take a closer look at what it says here. This is telling us that this merge request will close issue 42, which is the issue we have been working together all along. Let's merge the changes. As a platform engineer, when developers merge changes to the main branch, this will automatically trigger a pipeline to production, following in this case a GitOps pattern. Let's dig deeper into that. This is our path to production pipeline I have configured. As a platform engineer, I wanted to make sure to isolate the application building from its deployment. So developers can focus in a single project, while platform engineers can focus in the deployment one. Of course, this is invisible for end users, thanks to this multi-project pipeline that you can see here. This pipeline has finished. Let's go through the steps it executed. Our application container was built again. This is the container production image. And the application was tested by security scanners. Remember, these security scans always happened because they are coming from our compliance pipeline that we saw in the major use cases. And the third stage from this pipeline is a trigger to the deployment project. Now, going to the project in charge of deployment, the one that is independent from the building app, we will find that the triggered multi-project pipeline modified the Helm manifest files. Let's open the manifest and check its commit history. Here we see that this was done by the pipeline, and the tag of the image built in the previous project was commit here. And how did that happen? This happened thanks to the agent for Kubernetes. GitLab DevSecOps Platform can natively integrate with a Kubernetes cluster using this agent. Under infrastructure and Kubernetes clusters, we can see the integration here. Here is the agent and the connection status with the cluster. To implement this agent, we have created a directory for it and specified in a config file the path it should read for changes in the manifest files in this repository, since the files, of course, are under version control here. So whenever we update the image and automatically trigger the release of a new production app, as a platform engineer, I have configured the pipeline to update my release pages, showing me the binaries and version of our latest release here. Alright, let's finish our deployment mission. It was an easy mission, thanks to all the automation that as a platform engineer I have configured. By checking the environments page, here I can manage different environments where my app has been deployed. Let's open the production environment. And here it is. This is the app that GitLab DevSecOps Platform helps us to build, test, secure, and deploy. Using GitLab DevSecOps Platform, as you could witness, building a feature and taking it all the way down to production with me, help us to increase operational efficiency while reducing security and compliance risk. Building and maintaining our application with this platform approach allow us to bring together the entire software development lifecycle into a single application. Evidence of that platform mindset can be found here under Analytics and Value Stream. We see that by having this visibility into my software delivery lifecycle, I can identify and target inefficiencies. This gives visibility across personas working in the application and help us to optimize work streams. Let's bring our attention to DORA metrics. These metrics that are collected and aggregated in the platform help us to gain visibility into the performance of my delivery lifecycle. A quick glance to my development frequency tells me that there is a big room for improvement. So let's click on this metric. I can quickly tell that this team of one has been deployed mostly during the last week. The insights that you can extract from this data allows you to make business decisions. For example, as a manager, I will assign this engineer to build machine learning applications, since according to this contributor plot, is the one contributing the most. Overall, this feedback loop allows us for continuous improvement and as a result, faster time to value. Let's consider this scenario where we have an open incident and I have been working on it. I had a prompt response, as can be seen in the incident timeline, given the severity of this, and that I received an alert via an escalation policy. We have detected a bug in production, and my security department has identified that a good course of action is to enable a custom rule in our SAST scanner. Here we have the merge request that will enable that. Under changes, we can see the configuration file that I have added. This file here, let's take a look using the GitLab IDE, will take alerts of type CWE322, which means key exchanges without entity authentication, and from now on, we'll flag them as critical instead of high risk, hardening the response against vulnerabilities like this in the future. In other words, this merge request is customizing the rule set of our SAST scanner. Any code contribution that attempts to be merged must pass through the security scanners that, as a platform engineer, I have configured for this project along with the security and compliance managers. Here we see that we start by building the image using the Docker file defined in the repository. This container image will be pushed to the GitLab container registry. Here we have the image built during this merge request. Later, this image will be scanned using the container scanning. This container scanning job is searching for vulnerabilities that our Docker image may contain. This scanner is inspecting the application and system dependencies inside the image. And this, combined with the dependency scanning, right now is helping us to reduce as much risk as possible. Dependency scanning let us know if my application uses any external library that is known to be vulnerable, so we can take action and protect it. License scanning detects licenses in use. I can extract license information from packages where multiple licenses might apply, helping us to remain compliant while building and maintaining our application. Secret detection helps us to find early if someone may accidentally commit passwords, secrets, or API tokens. And here we run static application security, which scans for vulnerabilities such as cross-site scripting or unsafe code that can lead to unintended and dangerous execution. This scanner also provides vulnerability tracking. Let's say that a code fragment that has been detected to be problematic and has been moved around files in the codebase. This scanner helps us to track the code as it moves, and if the problematic code fragment moves to another location in the codebase, it will be reported again. And finally, a code quality job, which helps us to keep our code readable and easier to maintain. Readable and high quality code is less prone to produce unintended executions and complements the code review process. Moving to review, remember the GitLab agent for Kubernetes integration? Here we are using it again. This step is creating and deploying my application to an ephemeral environment in a Kubernetes cluster. This ephemeral environment will be used to run dust scanning against it. Alright, our review app or ephemeral environment has been created. Let's check out inside the dust job and see this scanner in action. Right now, the scanner is reading the URL of the review app and running attacks against it. Considering that some attacks might not be visible from the source code, but only when the application has been deployed, this combo here of GitLab review apps with Dust allow us to catch vulnerabilities before our application is deployed to the public, preventing us to suffer from a data breach as a result of a SQL injection, for example. Going back to the merge request page, we get an URL to the review app. Let's click on it. Here we see the environment that is under attack right now by the Dust scanner. Alright, the pipeline has finished. Let's take a look at the reports generated by the scanners. We noticed it was able to extract licenses of the packages used in this project. And there is a policy here, which tells me that among the licenses, there is one that I am allowed to use. That is good. The code quality scanner is showing me the areas for improvement when it comes to refactoring my code. Let's go back to the licenses. Checking this report, this tells me that I should probably add more license policies. To do that, I click on Manage Licenses. This gives us a view of the compliance policies that restrict or allow the usage of different types of licenses in my project. It has an approvals option where I can select a group or a team member to be the approver in cases such as finding denied licenses that are already in use in the main branch. Going back to the merge request page, we see here all the vulnerabilities this MR brings with it. And it highlights a critical one detected by the container scanner. Let's check it out. Clicking on this vulnerability will show us more details. And we can see that this vulnerability has not been dismissed. There is a confidential issue that was created from the scanner report and involves security faults for further investigation and remediation. Alright, let's go back to the merge request page and let's put this MR on hold at the moment. You might be wondering if I have this wealth of information only every time that I create a merge request? And the answer is no. Platform engineers, compliance managers, and security managers, and in general, any person interested in the security status of this project can learn about it by visiting the security and compliance capabilities offered by GitLab DevSecOps Platform. Under security and compliance, we can get information and a view of the trends about vulnerabilities being detected by security scanners. Using the security dashboard, we can see what has been detected over time, along with its severity. Clicking on Vulnerability Report will show me the development and operational vulnerabilities found so far in my project. I can filter these results by severity, status, tools, and activity. Let's filter by the no longer detected. Do you remember this one? We previously fixed this vulnerability while we were adding feature flags. I can filter by scanner and severity. And these are the critical ones that have been found. Alright, let's move on to on-demand scans. What if I want to run dust scanners outside of a merge request? This is what on-demand scans allow me to do. We can observe that in this case, I have defined my text analysis app and its production environment as the target application by passing the URL of the environment. And I have created a configurable schedule. In this case, every week we'll run a scan against my production environment. I want to click on the scan library and show you that I can trigger a scan right now if I want it. Alright, moving forward, under dependency list, we get the SBOM, or also known as software bill of materials, that is generated with each scan on the main branch. It provides the components that builds up the application, the packager used, the location of the dependency, whether it is a dependency within the container itself, or the Python package manager that I am using to build this app, along with any vulnerability that has been detected within that dependency. When we expand the description, we can find all the vulnerabilities detected for that particular component. If we click on a vulnerability, this will give us a report that can provide us more information and a solution if there is any known at the moment. From here, we can also manage the status of this dependency. We can triage, or let's say, in this case, I want to confirm that this is a vulnerability. I want to go back to the dependency scanner job and show you the CycloneDX report. Let's click on the job and the artifacts that it generated. This file will show us all the components that are part of our application in a CycloneDX format. And this is important because CycloneDX is a full stack bill of materials standard that provides advanced supply chain capabilities for cyber risk reduction. Alright, let's go back to our security and compliance dependency list. In general, GitLab SBOM enables us to assess the risk of vulnerabilities and mitigate them. You are familiar with license compliance. This shows us all the detected licenses found in the project and allows me to create policies to remain compliant. Moving forward, now let's go into policies. We can link another project to contain and manage security policies. This project here is in charge of managing the security policies that are being applied to my application build. We find this project under the same group along with the other services. Let's check it out. We see here the policy definitions that are being applied to my app. Having this separate enables for comprehensive and centralized policy management. Having all of our policies in another project, let us picture security folks in charge of this project, maintaining it, updating it in and out independently while being linked to the application development. What if I want to create a new policy? Let's do it. In the project that I want to have my policies applied, let's click on New Policy. And this will give us two options. Either a scan result policy, which means it will get applied after a scan is done. This is something we have configured already here. In our case, if we find more than 2 critical vulnerabilities, the policy will get activated and require approval from a team member. The other option is a scan execution policy, which could be a rule to enforce scan executions at any given time or schedule. Let's create a scan result policy to illustrate how friendly the creation of policies can be. Let's give it a name, configure the rules, and the action that it should lead to. Let's add the good Cesar as an approver and click on configure using a merge request. You see, after clicking on merge request, this directly takes me to the project in charge of policy management, living up to our aim to have a comprehensive and centralized policy management strategy. Once I merge this, the updated policies will be enforced on my application project. Let's finish where we started, in the merge request page. GitLab DevSecOps Platform helped me to integrate security early in the development process, allowing me to involve also security experts right where the vulnerability was found. My team can iterate on this merge request, and as a result, my organization is developing better software, more secure, and faster.